All right, so slope-intercept form is a y equals mx plus b. So slope represents the m, and that's the constant rate of change. And we will get to a point where we talk about the word problems where we're talking about the repeating value. The b represents the y-intercept, so that's where it crosses the y-axis. Okay, so the y-intercept is where it crosses the y-axis or the initial value. Linear functions they look like straight lines. So the example that we gave here is this one is going up from left to right. So it's always like you read a book from left to right, and that's got a positive slope, or we can say it is increasing. So this has a positive slope, or we can say that the values are increasing. Okay. So then we have a line that if we go from left to right, it's going down. We can say that that has a negative slope or it is decreasing. So we also looked at tables for a little bit. It said the linear functions have tables and they are a constant rate of change. So constant rate of change means that they're going to change by the same values every time. So if we look at this table, this slope is linear, or this change is linear because we're changing by -1. This one's going down by -1. Same thing here, -1. The x values are going up by +3, and it happens every single time, so therefore it is constant. So if we're looking at this example, my slope for this table is the change in y over the change in x. So therefore, the change in y is -1 over the change in x is 3. So if we look at this table, I'm going to be looking at from 13 to 17, that's going to be +4. From 17 to 21, that's +4. 21 to 25 and 25 to 29, those are all +4. So these are all constant changes in the y. So then my x's, these are +2, +2, +2, and +2. So these are both constant changes. So if we ask you what the slope is for the change for this table, it's the change in y over the change in x. So the change in y is going to be 4 divided by the change in x is 2. So that's going to be simplified to 2. Now we're going to look at some examples and some non-examples here. So if we're looking at an equation, so if I have y equals mx plus b, slope-intercept form, so 3x minus 1. Okay, so if I ask you to identify the slope of this example is going to be, let me color code this. So my slope for this example is going to be 3. The 3, well, the number being multiplied with the x is always the slope. That's the repeating value. So my slope is 3. And my y-intercept is always the number being added or subtracted. So it is a -1, so that's going to make it -1. Okay, so I can actually verify that it's crossing the y-axis at -1. So if I go to Desmos and I put y equals 3x minus 1, we'll get to a point where we look at slope, but I can see that right here where it crosses the y-intercept, that is in fact at -1. All right, so another example would be y equals -1/4 x, and I want to identify the slope and the y-intercept. So again, the number that's being multiplied with the x is always a slope. Y equals mx plus b. So my slope is going to be -1/4. And in this particular example, we don't see a b value. So we automatically know this is +0. So my y-intercept is crossing at 0. Now, just to kind of backtrack for a second, if you ever have a slope and you have to turn it into a fraction, that would be 3 over 1. Any whole number divided by, or any whole number is always going to be divided by 1. So again, if I put this in and I do y equals -1/4 x, so you can see that it's crossing the y-axis at 0. Now, some non-examples means what do I see that's not linear? So we're eventually going to get into all different types of problems, two types of functions. So what if I happens if I have squared? So y equals 4x squared. That's not linear because it's got two x's. That's actually called a power function or a quadratic because it has an exponent. Another example that we'll get into was what happens when I have an exponent that is a variable. That exponent that has a variable is called an exponential function. But again, these are all have exponents, so these do not represent a linear function. A linear function will have the number being multiplied by the slope. So always being multiplied by the slope. So again, some examples of graphs. So we talked about this just a second ago. It will always look like a line. So this will be a positive slope and it's increasing. We could also have our horizontal and vertical lines. We've talked about those in a previous lesson. So those are all examples of linear functions because they will look like lines. So some non-examples are things that have curves in them. So if they have a curve in it, this is the power function. That is not a linear function because it looks like a curve and doesn't have a straight line. Again, this one has curves in it. This one actually is an exponential function. So linear functions will always have straight lines. All right, so if we're going to look at some table examples, we're going to look at how do we actually identify the slope and the y-intercept from a table. So I'm going to make a table of values. And in these table of values, we're going to be able to identify the slope and the y-intercept. Okay, so the slope and the y-intercept. So when I'm looking at this example, the first thing I'm going to look at is I'm going to look for the y-intercept. So the y-intercept is always where my x is 0. So when I look at this example right here, my x is 0, so that means my y-intercept, my b value is 10. So now we're going to look at the changes happening here. So from 5 to 10, that's -5. From 10 to 5, that's -5. And from 5 to 0, that's -5. All right, then we have -3 to 0, that's going to be +3. From 0 to 3, that's +3. And 3 to 6, that's +3. So my slope in this situation is going to be my change in y over my change in x. So my change in y here is going to be -5. My change in x is 3. So I can actually write my linear function. I can write y equals, my m was -5 over 3, x, and but the y-intercept is positive, so plus 10. So another example. So remember, when we're looking at our examples, my y-intercept is always where my x is 0. So when I'm looking at a table, my y-intercept is always where my x is 0. So when I look at this table, my x is 0 here. So that means my y-intercept is going to be 4. So b equals 4. And now we're going to look and see what's happening. So we have -7, or 7 to 6 is -1. 6 to 5 is -1. And then 5 to 4 is also -1. So then we have 6 to 4 is -2. 4 to 2 is -2. And 2 to 0 is -2. So my slope for this one is my change in y over my change in x. So we have my change in y is -1 over -2, which is going to simplify to +1/2. And if you ever need to verify that, just put it in a Desmos. and do -1 divided by -2. It's going to give you a fraction, but there are decimal, but there is a fraction button you can verify with. All right, so if I want to write my equation, I have y equals, my slope is going to be m, so that's going to be positive 1/2 x. My y-intercept is 4, so that's going to be plus 4. Now, how do we know that we have non-examples of linear functions? So remember, non-linear functions will not be constant. So I can still identify potentially my y-intercept, but if their numbers are not changing by a constant value, it's not linear. So when I look at this, I have 4 to 3 is -1, but 3 to 1 is -2. So this is not constant, so it's not linear. Okay. So remember, linear functions have to be constant in their change. So another example, we have 1, 2, and 3, 2, 4, and 8. Now, in this particular situation, there is a pattern. We're multiplying by 2. However, we don't multiply when it comes to linear functions. We add or subtract. So we will get to a point where we talk about multiplying, but in this situation, linear does not multiply. Okay. Now, if I had asked you what the y-intercept is, I could have told you the y-intercept. The y-intercept here would be where x is 0. So I'm looking here, x is 0. My y-intercept would have been 4, but it's still not linear. So again, these are not linear examples here. So just to kind of review here, so y equals mx plus b. M is the slope, b is the y-intercept. If it's going up from left to right, it's positive. If it's going down from left to right, it's negative. When we're looking at a table, in order for it to be linear, it's going to have constant change, a constant rate of change. And we take the change in y over the change in x.